remember being told not to touch electrical appliances with wet hands. We're doing a deep dive into that today.
It's way more common than you might think.
Uh.
It's not just about safety warnings, understanding how electricity and liquids interact. It actually explains how we can use them for some really practical purposes.
Okay, now I'm really intrigued. So where are we headed with this deep dive? What's the source material?
We're taking a page from a science textbook.
Okay.
But don't worry, this is about as hands-on as it gets. This isn't like Bunsen burners and beakers. Think more like kitchen counter experiments.
Okay.
So picture this, a battery, a light bulb, some wire, and then just like a few common household liquids.
Ooh, I like where this is going. This is like a DIY episode of MacGyver meets Bill Nye.
Exactly.
So what's step one in our kitchen counter laboratory here?
First, we're going to build a simple tool to test if a liquid can conduct electricity. Just using the battery, the bulb, and some wire, we can create a basic electrical circuit.
Right, like you might remember from grade school science fairs.
Yeah.
Exactly.
You've got the battery as your power source. The light bulb is going to indicate whether the current is flowing, and the wire closes that loop. If the liquid can carry that electrical current, boom, the circuit's complete, the bulb lights up.
Exactly. And here's where things get really interesting.
Okay.
The results can be pretty surprising.
Okay, spill the beans.
Yeah.
What kind of surprising results are we talking? Does this involve potatoes? Because if so, you have my full attention.
You are in luck. It turns out even a potato can be part of an electrical circuit.
What?
Who knew? And it's not just potatoes, things like lemon juice and vinegar. These can also conduct electricity.
Wow.
It all comes down to the presence of ions.
Okay, ions. Give me a little refresher course here.
Yeah.
What exactly are ions, and what do they have to do with electricity?
Ions are basically electrically charged atoms or molecules.
Okay.
They are what allows a liquid to conduct electricity. You see, metals like the copper in our wire, they're excellent conductors because their electrons can move really freely.
Whereas materials like rubber or plastic are insulators. Their electrons are kind of held much tighter. They can't move as freely. So liquids with dissolved salts or acids, they contain these free-floating ions that act like little carriers for that electrical current.
So if a liquid has more of these free-floating ions, it's a better conductor of electricity. And I'm guessing that's why distilled water, as pure as it is, wouldn't be a great conductor.
You got it. It's all about those free ions. Distilled water, it's had most of its impurities removed, including those dissolved minerals and salts. So it's a very poor conductor.
Okay.
But tap water, on the other hand, with all its dissolved salts and minerals, is a much better conductor of electricity.
Which is why that age-old adage about not, bringing your toaster in the bathtub with you suddenly makes a lot more sense.
Exactly. And it's not just bathtubs. Being near any electrical appliances with wet hands is dangerous because of how well water conducts electricity.
Duly noted. So we've covered the basics. Liquids can conduct electricity, some better than others, but we also mentioned chemical reactions.
Right. What happens when we introduce a chemical reaction to this mix? This is where I feel like things could get really interesting.
You're not wrong. Let's take our simple tester, and instead of using plain water, let's use water with dissolved salt.
Okay.
What happens? We get bubbles.
Bubbles. So it's not just lighting up a bulb now. We're creating something new.
Precisely. Those bubbles tell us that more than just simple conduction is happening here. We're talking about electrolysis.
Electrolysis. Okay, that sounds serious. Break it down for me.
Okay.
I'm back in that grade school science fair.
Okay, imagine you could harness the power of electricity to literally rip apart water.
Okay.
That's essentially what electrolysis does. It's the process of using electricity to break down molecules.
Okay.
In this case, we're splitting those water molecules into their basic components: hydrogen and oxygen gas.
So those bubbles aren't just some random reaction. They're actually flammable gases. This is way more exciting than I thought a science textbook could be. It really is amazing when you think about it. It's like we take this really simple setup.
Yeah.
Battery, wires, water with some salt, and we're actually splitting apart the very building blocks of water. And this isn't just some cool science experiment.
Yeah.
Electrolysis has the potential to change the world.
Really? How so?
Well, for example, remember those gases we talked about?
Yeah.
One of those is hydrogen,
Right.
which, as you know, is being explored as a clean energy source.
Right.
So electrolysis is actually being used to develop new ways of producing hydrogen fuel.
So electrolysis could lead to cleaner energy solutions.
Okay, that's really incredible. But before we get too far ahead of ourselves, the textbook mentioned something else that happens when you switch up the ingredients a little bit. Instead of salt water, what happens if we use a copper sulfate solution?
Ah,
I'm sensing this is where things get really, really interesting.
you are right. This is where we dive into the fascinating world of electroplating.
Okay.
Imagine dipping a plain metal object into a special bath.
And it comes out coated in like gleaming silver.
Wait, what? For real? Tell me more.
So with our simple tester setup, if we swap out the salt water for a solution of copper sulfate and use copper electrodes, something really cool happens. One of the electrodes gets coated in copper.
Okay, you have my full attention. How does that even happen? It sounds like magic.
It might seem like magic, but it's really just clever science.
Yeah.
You see, we've already seen how an electric current can cause chemical changes in a solution.
Right, like splitting those water molecules.
Exactly. Electroplating takes advantage of this by using the current to deposit a thin layer of one metal onto another.
So in our copper experiment, the copper ions in the solution are basically gathering on one of the electrodes and creating a coating.
Exactly. It's like a microscopic metal factory
Wow.
with the electric current kind of directing traffic, moving those copper atoms around to build up that coating.
That is so cool. So we can coat things in other metals using this process. What's the point of doing that?
That's the beauty of electroplating. It lets us give everyday objects a superhero suit.
Okay.
It allows us to coat objects with metals that have desirable properties. Think about making things shiny, preventing rust, or even mimicking the appearance of more precious metals, all thanks to this process.
Okay, I'm starting to see where you're going with this. So it's not just a cool science experiment. This has real-world application.
Oh, absolutely. Electroplating is everywhere.
Electroplating is everywhere, you say. Like, what? Give me some examples.
Well, how about something you probably have right in your kitchen right now?
Okay.
Think about canned goods.
Yeah.
Those everyday heroes of the pantry. Those cans are made from iron, but they're coated with a thin layer of tin through, you guessed it, electroplating.
Whoa, for real. So my cans are little fortresses protecting my food with the power of electroplating. I had no idea.
Exactly. That tin coating, it prevents the iron from rusting, which keeps your food fresh and safe to eat. And it's not just about preservation. Electroplating, it's also how we get those shiny chrome finishes on cars, bikes, even bathroom fixtures.
So that brilliant shine on my car, it's not just for looks. It's actually a rust prevention strategy. Mind blown. What else? Give me another electroplating revelation.
Okay, how about this? Think about bridges. You know those massive structures that connect us across rivers and valleys?
Yeah.
A lot of them rely on electroplating to protect them from the elements.
Really? Bridges? How does that work?
Well, just like with the cans, we want to protect those massive steel structures from rust and corrosion.
Right.
So they're often coated with a layer of zinc. And this zinc coating acts like a sacrificial shield,
Okay.
protecting the steel from rust and extending the lifespan of the bridge.
Wow, that is incredibly clever. And to think, it all goes back to this simple process of using electricity to deposit a thin layer of metal onto another. It really is like giving these everyday objects a superhero suit. But are there any downsides to electroplating? It seems almost too good to be true.
That's a great question, and it brings up an important point about sustainability.
Okay.
The textbook mentions that those chemical solutions used in electroplating, they don't last forever.
Right.
In fact, disposing of them responsibly is a major concern, since some of those chemicals can be pollutants.
Ah, so our shiny chrome and rust-free bridges, they come with an environmental cost. I guess every superhero suit has its drawbacks.
That's right. It's a trade-off we often face with technological advancements,
Yeah.
But being aware of the potential downsides is the first step toward finding better solutions.
You are so right. So not only are we learning about this amazing science, this deep dive has also raised some really important questions, like how can we make sure that these processes are more environmentally friendly? That's something to ponder.
It really is. It's a challenge for scientists and engineers to figure out ways to make these processes more sustainable for the future.
Absolutely. So to recap for our listeners, today you've become amateur electricians and kitchen counter chemists. We've gone from a simple warning about water and electricity to understanding how this powerful force can be harnessed to split water molecules and coat everyday objects, all thanks to the wonders of electrolysis and electroplating. We've also learned that even the most commonplace things have incredible stories behind them, stories that highlight both the ingenuity of science and the importance of considering its impact on our world.
Well said. And it's a perfect example of how a seemingly simple question can lead us down this rabbit hole of fascinating discoveries. So keep those curious questions coming. You never know where they might lead you.
And on that note, we'll wrap up this deep dive into the fascinating world of electricity and liquids. Until next time, keep those minds curious and those questions coming.